let's talk about the conservation of mass. And the conservation of a mass is a law or principle that states for any closed system that means that it's closed to all transfers of matter and energy, so we have to say that it's isolated. The mass of the system must remain constant over time. So that means that the system mass can't change quantity if there's nothing added into the system, but remember, because it's a closed system, there's no way that can happen, or removed from it. So until you change the parameters of your system, the mass must remain constant. So you might have heard that matter can neither be created nor destroyed, and this is what that comes from, the law or principle of the conservation of mass. So we can say that things can be rearranged, so they can be rearranged or change form, so they can go from a liquid to a solid or something like that, but the total system mass will always remain the same. So another way to say closed system would be isolated. A system that is set apart from anything else. And this concept was developed by a scientist named Antoine Lavoisier. In the late 18th century, and he was a chemist, so he came up with this idea of the law or principle of conservation of mass. So when we're talking about things like radioactive decay or radioactivity or nuclear reactions, it's a little bit harder to see this principle because mass is actually different than matter. Matter might not be perfectly conserved in isolated systems, even though mass is conserved. And so that's an important distinction when we're talking about very, very minute quantities as well as things that are difficult to measure. So an example of the law of conservation of mass might be in the creation of water from hydrogen and oxygen. So let's talk about that example really quickly. So let's say we have 4 hydrogen atoms in 2 sets of 2, and we combine them with 2 oxygen atoms. So this is 4 hydrogens and 2 oxygens, but what we would really be writing this as, we'd have to keep each one of these sets together. So this would be 2 hydrogen molecules and 1 oxygen molecule. So this is the correct way to write this representation of these chemicals. So we have 2 different pairs of hydrogen molecules, H2, and 1 oxygen molecule, O2, and that would yield two things that look like Mickey Mouse, 2 water molecules. So if this is our oxygen, and these are our hydrogens. So our chemical equation would be 2 hydrogen atoms plus an oxygen molecule, or 2 hydrogen molecules, excuse me, not atoms, yielding 2 water molecules. So therefore, mass is conserved. We start with 2 times 2 is 4 hydrogen, 2 times an imaginary 1 here, 1 oxygen, and we wind up, or excuse me, 2 oxygens, 2 times an imaginary 1 is 2, and then we wind up with 4 hydrogens and 2 oxygens. So check, our mass has been conserved.